In this section, we're going to use our second definition for the 6 trigonometric functions to solve some right triangles. Let's look at our first example. I have triangle ABC with angle C equal to 90 degrees. So triangle ABC is a right triangle, C is the right angle. If B is equal to 24.5 degrees and side C is 2.34 feet, let's find the length of side A. So I'm going to begin by drawing a little diagram that I can label. I'll make that the right angle, so that's angle C. I'll call that A and that B. Now I want to label it so that angle B is 24.5 degrees. So 24.5 degrees for angle B. Side C is 2.34. So I'll label that 2.34, and I'm looking for side A. So I've labeled my triangle with all the given information and the side that I'm looking for. Now what I need to do is look for a trigonometric function that relates this angle and these two sides. Well, with respect to this angle, this side is adjacent to it and this side is the hypotenuse. So when I talk about adjacent and hypotenuse, I'm talking about the cosine function. So I'm going to write this relationship down. The cosine of 24.5 degrees is equal to the adjacent side A divided by the hypotenuse 2.34. So I solved this equation for A by multiplying both sides by 2.34. I'll also reverse the two sides and I end up with A equals 2.34 times the cosine of 24.5 degrees. On a calculator, I look up the cosine of 24.5, I multiply by 2.34, and the result comes out 2.13. Now put in my units feet. I round to the nearest hundredth, so I have 3 significant figures here because my original side had 3 significant figures and my angle is to the nearest tenth. So following my rule for significant figures, that side comes out to be 2.13 feet. So I just simply draw a diagram, I label the parts I'm given and the part I'm looking for, I look for a trigonometric function that relates all 3, and the rest after that is algebra and a little calculator work. Here's another problem. This time I'm given angle A. Side A is 16 centimeters, side B is 26 centimeters, and I want to find the measure of angle A. So again, I'll begin by just drawing a diagram. Doesn't have to be accurate, I just need something to label. Here's angles A, B, and C is the 90-degree angle. Side A is 16 centimeters, so I'll label side A with that. Side B is 26 centimeters, so I'll label side B with that. And then I'm looking for angle A. So this is what I want to find right here. So I have to ask myself now, with respect to this angle and these two sides, what trigonometric function relates all 3 of those? Well, with respect to this angle, this side is opposite and this side is adjacent. So I have opposite, adjacent. I must be talking about the tangent function. So I'm going to write down that the tangent of angle A is the side opposite, 16, divided by the side adjacent, which is 26. Okay, I do the arithmetic there, and I'll just show you 4 significant figures. That comes out to be 0.6154. And that's my tangent of angle A. I hit my inverse tangent button on the calculator. So I use my inverse tangent button, and that will give me A. Let's see, 2 significant figures, or the nearest degree, 32 degrees. So I have to round off according to my rule for significant digits. Here I have 2 significant digits, 2 significant digits for the sides. When I'm in that situation, I want to round my angle to the nearest degree. So again, I have a triangle I label with the given information and the information I'm looking for. I look for a trigonometric function that relates those items. The rest is just a little bit of algebra and some calculator work. Here's our last problem. I have this diagram right here with a circle, 2 radii right here, a right triangle where this is the right angle, this from here to here is labeled X, and this angle is labeled A. Okay, suppose A is 31 degrees and R is 12, let's find X. So what I'm going to do here is look at angle A. I have the side opposite angle A is 12, and the hypotenuse is 12 plus X because R is equal to 12. So I'm going to write the relationship this way. The sine of 31 degrees is equal to the side opposite, which is 12, divided by the hypotenuse, which is 12 plus x. So here I have this equation, sine 31 degrees is 12 divided by 12 plus x. I need to solve this for x. So I'm going to begin by multiplying both sides by 12 plus x. I end up with 12 plus x times the sine of 31 degrees is equal to 12. Little distributive property here. Remember, sine 31 is just a number. So sine 31 degrees is a number. I'm going to multiply times x and times 12. I get 12 sine 31 degrees plus x sine 31 degrees is equal to 12. Now here's my only term with x in it, so I'm going to leave that on this side. I'll subtract this from both sides. X sine 31 degrees is equal to 12. Subtract 12 sine 31. Okay, and now I want to solve this for x, so I'm just going to divide both sides by sine 31. This is just a single number, so I can divide both sides by it. X is equal to 12. Subtract 12 sine 31 degrees, all divided by sine 31 degrees. And let's see, if I do that on a calculator, I'll end up with 11.3. And let's see, I want to round off because here this is the nearest degree and the side is 2 significant digits, so I'm going to round that off to just 11. So if I do this work on the calculator right here, this comes out to be 11, kind of a complicated looking diagram. I still look for a trigonometric function that relates the things that I'm given right here, and then the rest is a little algebra and some calculator work. So here's the distributive property, and don't forget that this is a single number.